In this video I'm going to discuss scatter graphs. I'm going to start with explaining what correlation is, and then I'm going to say something about drawing the line of best fit. Correlation is said to exist when there is a relationship between two variables. So for example, as temperature increases, ice cream sales may increase as well. So there could be said to be a relationship or a correlation between temperature and the sales of ice cream. Causation, on the other hand, is when something causes something else, as in cause and effect. So if I kick a ball, it will move. That's cause and effect. Let me show you some examples of scatter graphs which are correlated. So this first one shows height and the length of arms. As you'd expect, as height increases, so the person's arm length increases as well. So positive correlation: when one variable increases, the other variable increases as well. Negative correlation exists when one thing increases, the other value decreases. So this is showing the age of a car and the value of a car. As the car gets older, its value is decreasing. So that's negative correlation. And this final one is an example of no correlation. There is no relationship between how far I need to travel to go to work and how much I earn. And this is shown by all these points not being in any kind of discernible pattern. So if I've got the beginnings of a scatter graph where I've got the age of a car against the value of a car, you'll be given some values to actually plot. So if the age of a car is quite low, it might be a new car, the value is likely to be high. If the age of the car is old, its value is likely to be low. So newer cars have a higher value, older cars have a low value. So you will end up with some points scattered roughly around a line going through here. So I need to draw a line of best fit, which is roughly an equal weighting between all the points. So if I draw it like that, and as you can see I sort of tip my ruler on the end so I can look down and see roughly how the points are scattered. Now you'll notice that I've not continued my line past or before my last points, because there is no way of knowing what might happen in these regions. Say also, for example, I've got a point up here. That point seems to buck the trend. This is showing an old car with a high value. So this is what you would call an outlier. If there are lots of outliers, then in effect you may have no correlation at all. So this outlier could represent a classic car because it's an old car with a high value, could be in high demand. If you're asked to find the value of a car, you need to use your line of best fit. So if I'm asked to find the value of a car which is say 1 year old, you would find where the 1 is on the age, and then you would use your ruler. You would draw a line up to your line of best fit, hit the line of best fit, draw a line across and read off the corresponding value here. In an exam, please do draw these lines in because in effect it's showing you're working out. Now if the actual value does manage to hit the line of best fit, that's what's called interpolation. The word inter means between. So your value is between the poles, or the beginning and end of your data. If you're asked to find the value of a car which might be say 7 years old and you've got no data, so basically if you were to draw a line up here, it would not hit the line of best fit. So what you could do is you could carry on your line of best fit and you'd be then assuming making a big assumption, and therefore your data would not be as reliable. So you would be estimating the age to be this. So if you're asked to find the value of a car which is 7 years old, what you're doing there, you're doing what they call extrapolation. Extra means outside of the poles of the data. Extra as in maybe extraterrestrial.